Hi, how you doing? Ready for more on the harmonic oscillator? Before we move on to the next chapter, let's recall something we have already talked about, and let's do some calculations with that. Let's talk about Fourier analysis and how that can be very helpful in this context. We have worked out the solution of the harmonic oscillator on the periodic external forcing. So, whenever we have a periodic forcing on an oscillator, we already know how it is going to behave. We know there will be a transient. We know that the system will follow the external forcing frequency, and we know that there will be a resonance frequency. We also know that if there is no damping, the system will eventually break down. Now, because we know that every well-behaved periodic function can be written as a series of sines and cosines, we have the solution for a wide variety of external forcing. If we have a series of external periodic forces acting on a harmonic oscillator, their steady solutions can be written as where the phases are. Let's consider f of t is a periodic function such as that. Then, after Fourier theorem, we can write where but because the function f of t is periodic, the period t is 2 pi over omega, and we can replace the limits of integration to just one period. So this is how we write the periodic function f of t in terms of sines and cosines. For example, let's consider the function minus 1 4 times between minus pi over omega and 0, and plus 1 4 times between 0 and pi over omega. This is an odd function, so the odd terms in the Fourier series survive, but even terms do not. So only the b sub n coefficients are different from 0 here. And b sub n is omega over pi times the integral from negative pi over omega to positive pi over omega of f of t prime sine of n omega nt dt prime. Let me integrate this. So b sub n is 0 for n even and 4 over n pi for n odd. So this force can be written as 4 over pi sine of omega t plus 4 over 3 pi sine of 3 omega t plus 4 over 5 pi sine of 5 omega t, and so on. Now, let's plot these using our computer. I'm going to plot the first terms and see how this gets closer to this step-shaped function. For more terms, the more terms I consider, the closer to f of t I should be getting.